Welcome to Bioinformatics with BB channel. My name is Babajan Banaganapalli. I'm an associate professor in Bioinformatics. In this video, we are going to see how we can install the Gromacs in Windows, and also these steps are very similar in the Linux. And I'm also going to show you a simple molecular dynamic simulation tutorial and protein and water system. Okay, if you have any error or any other troubleshooting issues in bioinformatics, you can post your comments in our Facebook page. So Facebook group page here, this is the Facebook group page here. You can post your comments here. Experts in this group can answer your question or answer your queries. And also, if you have an account in Instagram, you can follow us on Instagram. Different kind of free softwares we are posting every week in Bioinformatics with BB Instagram channel. So I'm going to provide a links in the description box. Please check that one. Okay, so let's give the basic introduction to the molecular dynamics simulation. So molecular dynamics simulation is an artificial method to understand the atom behavior. So here we are going to create an artificial environment and trying to mimic the behavior of atoms in a real life. So by assuming the given potential energy of atom, the energy function at the fixed period of a time allows us to calculate the force experienced by the atom at a given position of the other atom. So there are many tools are available to perform the MD simulation. Each and every one has its unique properties, unique method to perform the MD simulation. Okay, you can see here some of the popular ones are the like Amber, Charm, Desmond, Gromacs, Fold Home, Lamp, NAMD, etc. So I'm going to provide the links in the description box. Please check that one. If you have any doubts in the installation, you can just post that one in a comment box, or you can post the comments in our Facebook group page. Okay, so let us start about the basic introduction to the Gromacs. Gromacs is one of the most fastest and accurate software package for doing the molecular dynamics simulation in various kinds of macromolecules like protein, lipids, and nucleic acids. Okay, so what are the system requirements are needed? Generally, I am using Intel Core i7 processor with the 32 GB RAM, 1 TB SSD card, 1 TB SSD hard disk. Okay, and also I'm using the 8 GB graphic card. And so I have Windows Pro. So this is a new laptop I got, new configured system I got it. So I don't have Ubuntu in my system. So soon I'm going to install the Ubuntu also. I'm going to show you how we can run the MD simulation in Ubuntu. So here now I'm going to show you how we can install the Gromacs in Windows. And as I told you, you can use the same commands in Ubuntu and also Federo, or if you are using the CentOS advanced version, and also if you are using the Mac also, you can use the same kind of options. And we are going to also going to see as a simple molecular dynamics we are going to check in today's video. Okay, let's start. So go to start page and click Windows feature. Okay, so here click on Windows feature and scroll down. You will find a option called as a Windows subsystem of Linux. Okay, make a tick of this one and click OK. So wait for a few minutes. Once the installation is done, you have to restart your system. So just now I restarted the system. Okay, you have to go to the store. Okay, so go to the store, click on Ubuntu or Linux. So here I click the Ubuntu or Linux. Okay, so once you got this one, you have to click install. Depending upon your internet speed, it will take some time. I think it's so just now we got installed. Installation is done. Once it is done, click on launch. So initially you have to give your username. So I'm going to give my username as a bioinfo and just type the password. So now we completed the bash, so you have to retype the password. Okay, so now we completed the bash. We created this Ubuntu bash here in Windows. Now it's time to install few supporting files for the Gromacs. Okay, first we need to update our bash. So sudo apt update, or you can type sudo apt get update. Okay, next step is sudo apt get upgrade. Yes. So next step is we have to create a make files. We have to install the GCC. Okay, so compatible libraries sudo apt get install GCC. Sorry, install GCC. Yes. Okay, so next one is we have to sudo apt get install cmake. Yes, sudo install build essential. Yes, yes. Okay, sudo install lib ffdw3 dv. Yes, sudo install. Now it's time to install the Gromacs. That's it. We don't need any time. You can see here the Gromacs has been installed. You can see the 2020 version has been installed. If this not work for you, you have to use this option. Okay, so you manually have to download this Gromacs from the Gromacs website. Okay, you have to save that one on desktop. You can use the same option in uh, if it is not work for you in a Linux, you have to go through the same options. Okay, first download the Gromacs software. Okay, so here let's see. So just we need to go to the that folder. If you want to go to the folder in a desk in a Windows, you have to use the same kind of command. You have to use a cd mount. Okay, cd users here. Desktop. Sorry, my path is to dad. Yeah, desktop and the group, and that's it. Okay, this is the location now where the zip file has been saved. Now you have to give the sudo. Now we need to unzip our command tar xfz Gromacs 2002.3. Okay, so here dot tar dot tc. So with the password, so it will take just one less than 1 minute. Okay, so here, so it's completely unzipped. Now we need to enter into that folder cd Gromacs 2020-3. Okay, so now we are going to make the directory mkdir build. mkdir build. Okay, build. Okay, so here, okay, cd build. Just to copy the same command here, you have to copy the same one exactly. Okay, so click here sudo and enter. So you have to remember one point here. If you want to work on the graphical processor unit, initially you have to install the CUDA package or OpenCL package in Linux library. Okay, I'm going to provide the link in the description box where you can easily you can easily install the GNU based Gromacs for you. Okay, so here the next step is the make. We have to write the make and click on cmake sudo make check sudo make check. So we have to check the make check, and finally, so we have to install the make sudo make install. So here, if you apply the cmake, it's going to take a long time for you for doing all this command. Approximately, it's going to take a 1 hour for you to install complete libraries of the Gromacs. Sudo make install. Okay, the finally we have to get the path of our. Okay, so here we have to do this. We have to move this one to the bin folder. Okay, now you can see here, if you type the gmx to gmx, you will find that advanced version has been installed. The new version has been installed here in this Linux. Okay, I just want to give one more advice for you. If you want to run the MD simulation for a longer period, my advice is better to use the Linux system. So Gromacs is mostly compatible with the Linux libraries, and also in Windows, in Bash cells, it's not compatible to install the GPU libraries in the Bash cell. So you need to have a dedicated operating system where you can install this GPU graphical processor units. If you're able to run the Gromacs in a graphical processor unit, Gromacs can run three times faster on a system accelerated with the GPU. To install this GPU processor, you have to install GNU compiler. It should be version more than 4.7 or later, and you have to install the CUDA tool. Depending upon the type of graphical card you're using, you're going to get different kinds of versions there. So luckily in the Linux, automatically it will recognize, it will install that one for you. So I'm going to add in a description box how to install the CUDA toolbox in a Linux. Check in the description box, I provided a link there. So just follow the same step. It's very easy to install. Okay, so sometime you will get like a apt get sudo apt get install kudo. It can install the kudo packages in Ubuntu or Linux. Once you've done that one, so you have to run this command. You have to go to the same way as we did for the Gromacs installation. So Gromacs installation, you have to create a directory. Go to the directory and make a cmake command and write down this statement. Okay, so if this command is not work for you, you can see here, these are the some of the script you have to make, you have to write down. So first, let us see, we are going to take this protein, okay, to do the molecular dynamics simulation. Okay, so here, download the structure and save this one on a desktop. Okay, so here I save this one on a desktop. So once you download the structure, first thing we need to do, we need to extract a protein chain. You can see here there are various chains are available, A, B, C, D, E, F. 4 different chains are available. So here I'm going to extract only a one chain. I want to do molecular dynamics simulation with this with the one chain. So I'm going to extract a chain. Manually I open the notepad, and I'm just copying the chain A PDB coordinates. So here, okay, so here tar. So up to here I'm copying this information. Okay, click new. So here paste here. So here the single chain we will type down here. We'll get name single chain PDB. Okay, so here, so on desktop I pasted this one. Okay, so here, so once you save this one, now this is the only one chain one. So first of all, we have to check whether the missing atoms are there in this protein structure or not. If the missing atoms are there, so first of all we have to repair these atoms. Otherwise, it is always a problematic for us when we are doing the molecular dynamics simulation. Okay, so these missing atom or residues must be modeled by using either software package, or we have to use some alternate method to repair the atoms. Okay, so here we are going to use a software called a SPDB. So I will show you here. Okay, so let me check, show you that the missing atoms are there or not there in this protein structure. Okay, let's run the first command. So here I'm going to write down. So here I'm going to go to the location. So let us save this one as in a one folder. So write down Gromacs or otherwise MDS. So I'm going to save this one here. Okay, so now go to back to location, cd mount C drive user desktop. Okay, MDS. Okay, so I went to location now. Now it's trying to run the command, first command, pdb2 gmx command. So let's try the command here. So here gmx pdb2 gmx minus f input file. So here single.pdb minus o 1.gro minus p 1.top file and minus water, it should be spce. Okay, so here let's assign the force field, the OBLS force field. You can see here the fatal error has become. So it has been consist of so many missing hydrogen atoms, different atoms are missing here. So here, so always you will get this kind of problem when you have a missing atoms. Okay, so these things can be resolved whether we have to model the structure or we need to use the program called as a SPDB. So here we are using the SPDB. So here this software is freely available for you. I'm going to provide a link in the description box. Download it. It's a very good tool. So here just open this one, open PDB on desktop. Open the PDB here, desktop, go to desktop. Okay, so you can see here it will show you some amino acid side chain atoms are missing. A reconstruction of whole side chain will be attempted. Affected amino acid will be appears in a pink. So you can see here automatically the program will be automatically rebuild up missing atoms. Okay, so rebuild the missing atoms. So simply what we need to do is, so we need to do anything, already the complete model has been reconstructed. So simply go to select all and here save select the residues of current layer and we'll type as a modified dot pdb. Okay, so modified dot pdb. So I'm going to save this one. So let's run this command one more time. So gmx pdb2 gmx command, first step in MD simulations. So this command is reads a PDB file as input. Okay, and we have to select the specific force field depending upon the type of system we are working, and also it will add hydrogen to the molecule and generate a coordinates of Gromacs and topology format files. Okay, there are three different format files it will generate automatically. So one is a GRO file, that is consists of a defined force field, and also the top file, which top file consists of non-bonded and bonded parameters such as atom type, charges, bonds and angles, dihedral angles. It all consists of all these things. So the ITP file also it will generate. It will file that contain the information of rest and the position of heavy atoms. Okay, so we majorly have to note down the force field need to be compatible with your system. If you want to know how you can specifically assign a specific force field for your protein or for your solvent, you have to read the manual. Minus ppt gmx. Okay, so input file minus f modified. So these are the modified version from the SPDB. So here minus o 1.gro minus o 1.gro minus p 1.top file, and we have to give the water as SPC. Okay, so one more thing you have to remember, if your protein has been crystallized through NMR structure, you have to use minus, for example here, so minus, you have to use minus IgNH. Okay, so if you use this option, it will ignore the hydrogen atoms. If your protein consists of hydrogen atoms, it's going to make a lot of trouble when you are carrying the MD stimulation in the next steps. Okay, so don't worry about not right now. Our structure is belongs to the X-ray crystallography, so here I need not to worry about it. So now run this command. So you can see here now it's showing the different kinds of force field for you, as I told you. So you have to carefully check which particular system is working suitable for which particular system, or which particular force field is suitable for your system. You have to select them. Okay, so I'm going to select the OPLS force field. Now you can see here the program has been completely smoothly run. So it showed a total number of topology file information for you, like dihedral angles and bond length, how many pairs of bonds are there, and also torsion angles. Okay, and also it will show you total energy, how much total energy has been applied, and what is the mass of this particular protein. It will show you complete information for you here. So if you want to cross check this one, you open this folder, you can see here there are three files has been generated. One is the ITP file and the grow file and also top file. Three files has been generated by using this one command.